Okay, all I want to do in this video is solve 3 problems using the acceleration equation. So let's get started. Here is the first one. Let's see here. Oops, what's this? Okay, so look at this. It says a cyclist accelerates at a rate of 7.0 meters per second squared. And remember, that's the same thing as meters per second per second. How long will it take if the cyclist to reach a speed of 18 meters per second? Okay, so let's see here. Let's make a list of the variables. We got A, we got VF, we got VO, and T. So what do we know here? We know that accelerates at a rate of, so that means A is 7 meters per second per second. And he's going to reach, I don't know why I assumed it was a he, but they are going to reach a speed of 18. So that means that's their final velocity. So that's 18 meters per second. And even though this problem doesn't say it, I think we're supposed to assume that the original velocity is 0. They were sitting still. So the original velocity was 0 meters per second. So that means the only thing we have left to find is the time. And if you read the question, what does it say? It says, how long will it take? So that is indeed the time. So let's solve it. If we fill in what we know, A is 7 meters per second per second. VF is 18 meters per second minus VO and divided by the times, and we don't know the time. So this is a trick that seems to work well with my students, so I'm going to use it here. Notice that this side is a fraction and this side isn't. So what I'm going to do is I'm going to turn this side into a fraction, just so that way I can bow tie, I can cross multiply. So let's take care of this one first. 1 times anything is anything, the same number. So 18 meters per second minus 0 is 18 meters per second. And that's going to equal this other side of the bow tie here. So 7 meters per second times t. So if I want to get rid of this multiplied 7 meters per second, what do? All I have to do is divide by 7 meters per second. So 7 meters per second, I'm sorry, per second, meters per second. So if I do that, it cancels out on this side, but whatever you do to one side, you got to do to both. And what are we going to be left with? We are going to be left with our units are going to be seconds, and that fits well because we're looking for a time, right? Time is what we want, so it should be in seconds. So all we have to do then is go 18 divided by 7, and that's going to be 2 point something. 2 point what? We will see. So 18 divided by 7, and I'm going to call that 2.57, so that's 2.57 seconds. So there's one problem. I want to do 2 more, and I kind of dawdled a little bit on that one. Maybe I'll go a little bit faster. Okay, so problem number 2. Let's take a look at this. All right, so let's see if we can dissect this one. What do we got here? So a driver slows from this to this. So maybe I'll use a different color there. So from that to that, and then the 12 seconds is the time. So while traveling on a highway, the driver slows from 24 meters per second to 15 meters per second in 12 seconds. And the question, of course, is what is the acceleration? So this one should be pretty straightforward. Might even be easier than the last one. So acceleration is VF minus VO over t. So between these two, which one was done last? Which one is the VF? Well, that would be, that would be this one right here, the 15 meters per second. And the original velocity was 24 meters per second, and the time was 12 seconds. So what do we have on top? 15 minus 24. Let's see, that's negative 9 meters per second. And divided by 12 seconds. So meters per second divided by seconds, seconds is divided twice. So our answer is going to be meters per second per second. Remember, accelerations have 3 units. And negative 9/12, that's reducible. 3, 6, 9, 12. So that's negative 0.75. And just because I'm paranoid, I don't want to put something on the internet that's totally wrong. 9 divided by 12. Okay, not that I haven't done that before. I've made lots of mistakes. But anyway, there's our answer. So there's a second problem. It's negative 0.75 meters per second per second. And what does that negative mean? That means that our acceleration was negative, or it was slowing down. Okay, so a third problem. Here we go. Let's stick this one on here. Whoa, how about there? Okay, so let's see here. A cart rolling down an incline for 5 seconds. So as we decode this, 5 seconds, what's that? That's a time. Let's go back here. An acceleration of, so that means that's going to be our A, our acceleration, 4 meters per second squared, or meters per second. And if the cart has a beginning speed of 2 meters per second, so that is our VO, and then the question must be asking for the final speed. So we want to know VF. So let's fill in what we know. A equals VF minus VO over T. So 4 meters per second equals VF, which we don't know, minus VO, and that was 2 meters per second, divided by T, and that was 5 seconds. So let's do this, the same bow tie method trick. If I notice that this side is a fraction, whoops, and the other side's not a fraction, I can turn it into a fraction by putting it over 1, and then I can bow tie. So I've got this times this, and that's going to equal this times this. So let's see here. 1 times anything is the same thing, so I'm going to have VF minus 2 meters per second equals 4 times 5, that's going to be 20, but one of my seconds is going to cancel, so that's going to be 20 meters per second. See how that happened? I've got meters per second, and that got multiplied by seconds. So since this seconds was by itself or on top, and these are both on the bottom, one of them is going to cancel. So anyway, if I want VF by itself, and I knew the whole dang thing was disappear on me. So yeah, if I want the VF by itself, I need to add 2 meters per second to each side. So this is going to go away. And so my final answer is going to be 22 meters per second. And that is my final velocity. There you go.